let's analyze the process that converts regular materials into pristine, clear, flat glass. Every day, hundreds of tons of raw materials arrive at our FG plants and enter the batch house. The batch house is where materials are precisely tested, measured, and mixed into a batch of dry ingredients that later become glass. In addition to mixing batch, Cardinal employs a process called cullet recycling. Cullet is broken glass that is returned by customers and is mixed back into the batch. This environmentally friendly program reduces the need for raw batch ingredients by at least 15%. The full batch is then conveyed to an enormous 36-foot wide furnace that reaches temperatures of up to 3,000 degrees Fahrenheit. A charger pushes the batch materials into the furnace. The heat transforms these raw materials into a 4-foot deep pool of liquid. The liquefied glass then glides across a molten bath of tin. In the tin bath, the glass spreads into a wide sheet or ribbon where it is pulled and shaped into a precisely controlled thickness. It is here where skilled technicians can make adjustments to the glass configuration. The process is monitored continuously from the control room to ensure quality. The control room is the nerve center of the plant. Here, a manager oversees the float line and directs technicians to perform various tasks. When the glass exits the tin bath and enters the annealing layer, the ribbon lifts right out of the tin. As it passes through the layer, it is cooled slowly to control the stress on the glass and ensure uniformity of thickness. The mass air section is the final phase of the annealing layer. This is where the glass is bombarded with air, driving the temperature of the glass down to where it can be cut. 20 miles of glass ribbon pass through the plant's cold end, producing more than 600 tons of glass each day. Defects in Cardinal's raw glass are almost unheard of. This is due to an advanced system which includes cameras for defect detection, lasers for edge detection, and special lighting for manual spot checks. If defects exist, they are automatically marked, and the cutting system cuts around the portion that is out of spec. The XY cutters score the glass with an amazingly accurate precision. After scoring, the glass is snapped with a bump roll which causes it to break along the score lines. All of the glass gets edge trimmed. The unused trimmings are captured below and is reused later as cullet. Each glass pane then travels in real time through a computerized routing system. Arriving at the packing station, the airside orientation of the light is carefully managed. This becomes important at low-E coating operations, where perfect, untouched surfaces are critical. Thus, great care is taken to package, wrap, and label the orders before they are transported to the customer in record time.